In this second video on indices and logarithms, I'll be talking about laws of indices. Okay, some of those laws we started encountering them little by little from the first video, but here we are looking at them fully. Okay, laws of indices, like I said already, indices tell us about how many times a number called a base multiplies itself, and we also call them exponents. So indices are exponents like that. So the learning outcome here would be that by the end of this lesson, learners can simplify expressions involving indices correctly, explain why each law works, and apply multiple laws in one expression. So let's go ahead and look at this. Okay, so first of all, the first law we are looking at is the product law, which we encountered in the first video, by the way. So, product law of indices. So, the rule simply says that if you have a raised power m, all right. If you have a raised power m multiplied by a raised power n, that's equal to a raised power m plus n. So we saw that work before. Why does it work? If you have 2 raised power 3 times 2 raised power 2, in the expanded form, 2 raised power 3 is 2 times 2 times 2. If you have 2 raised power 2, that's 2 times 2. So if you put everything together, you have 2 times 2 times 2 times 2 times 2 times 2. So at the end of the day, you just have 2 raised power 5. So since you have seen it like that, there's no point wasting time because you've tested the long way, you discovered it always results to the same thing. So you can then know that 2 raised power 3 times 2 raised power 2 is simply the same thing as 2 raised power 3 plus 2, which is equal to 2 raised power 5. So we add the exponents because we are counting the total number of repeated factors. So that's why we can just add the powers. So a raised power m plus n is equal to a raised power, a raised power m times a raised power n is equal to a raised power m plus n. So we have some examples. Imagine that you have x raised power 4 times x raised power 7. Okay, so that simply means you have x raised power 4 plus 7, that's x raised power 11. On the other hand, you have 5 raised power 3 times 5 raised power 6. That means you have 5 raised power 3 plus 6, that's 5 raised power 9. Then this is important. The bases must be the same. If the bases are not the same, it won't work, right? So for instance, you can't say 3 raised power 2 times 4 raised power 2 is 3 raised power 4 or 4 raised power 4 or 3 times 4 raised power 4, which is 12 raised power 4. No, the bases have got to be the same. If the bases are not the same, no, you can't apply the product law of indices, right? So when you're multiplying two numbers, um, that can be translated to the same base with different indices. All you just need to do is maintain the base and add the powers, and that's it. The bases have got to be the same. If the bases are not the same at first, prima facie, like at first sight, you have to find a way of converting. If you cannot convert, then you can't do it. All right. So we move on to X. Of course, there are other ways you can do some more advanced ways, but that's not necessary here right now. So we have quotient laws of indices. We've seen the product laws of indices. Now we want to see the quotient laws, which we also came across in the last video also, right? So here, maybe I should expand this because it's so important. So quotient law of indices tells us that if the rule is that a raised power m divided by a raised power n is equal to a raised power m minus n. All right. Of course, this also means that this is the same thing as saying a raised to power m divided by a raised to power n. It's basically the same thing like this. Okay, so we are simply saying the same thing here, that a raised power m divided by a raised power n is equal to a raised power m divided by a raised power n, which is equal to a raised power m minus n. Now the question is, why does that work? Okay, why it works is that if you have if you have it works because if you have 2 raised power 5 divided by 2 raised power 2. If you expand it, that means 2 times 2 times 2 times 2 times 2, all over 2 times 2. So 2, these two cancel, will cancel 2 here. So if you cancel common factors, you have 2 raised power 3. So we can simply say that 2 raised power 5 over 2 raised power 2 is the same thing as 2 raised power 5 minus 2, which is 2 raised power 3. Then we subtract exponents because common factors cancel themselves. So we can take some instances of this. Okay, let's just look at these first two examples. for the quotient law, you have x raised power 9 over x raised power 4. That is equal to x raised power 9 minus 4, which is x raised power 5. On the other hand, we have 7 raised power 6 all over 7 raised power 8. That means we just have 7 raised power 6 minus 8, which is 7 raised power minus 2, because 6 minus 8 is minus 2. And that is, of course, we saw this in the first video, that when you have a negative thing like this, so this tells the minus tells you you can now write the reciprocal of that without the minus. So you have 1 all over 7 raised power 2, which is 1 over 49, if you care to take it that far. Then we have special cases. Of course, if you have a raised power 0, that's 1 always. So a raised power 3 all over a raised power 3, is equal to a raised power 3 minus 3. And that is equal to a raised power 0. And anything raised power 0 is 1. We saw that in the last video. So let's go ahead and talk about power of a power. So how do you take the power of a power in indices? So the power of a power, for instance, you have a raised power m raised power n. That is simply a raised power m multiplied by n. So a raised power m raised power n is simply a raised power m times n, like that. So why does that work? Again, it works because if you have 2 raised power 3 raised power 4, that means you have 2 raised power 3 in 4 places. That means 2 raised power 3 times 2 raised power 3 times 2 raised power 3 times 2 raised power 3. So if you then add, based on the product law of indices, then you have 2 raised power 3 plus 3 plus 3 plus 3. That's 2 raised power 12, which is simply the same thing as multiplying 3 and 4. You have 2, you then have 2 raised power 3 times 4, and that is 2 raised power 12. So we simply multiply the exponents. So you have these examples that x raised power 5 is raised power 3. That's x raised power 5 times 3, 15. 4 raised power 2 times 6, that's 4 raised power 12. So, and then we talk about the power of a product, the power of a product. What if you're multiplying two numbers, and then these two numbers together, you raise them to a particular power n? You are multiplying a and b, and you now raise a and b, everything to power n. So that can simply be expressed as a raised power n multiplied by b raised power n, like that. And it works because if you have 2 times 3, 2 times 3 raised power 2, that means 2 times 3 is 6. 6 raised power 2 is 6 squared, and that is 36. But if you use the law tells us, so yeah, if you apply the law, it means 2 times 3 raised power 2 can be written as 2 raised power 2 times 3 raised power 2, which is 2 raised power 2 is 4, 3 raised power 2 is 9, 4 times 9 is 36. It's the same thing if you multiply 2 times 3, 6, and square it, you get 36. So the exponent applies to each factor inside the brackets. That's what that is telling us. So if you have 3x raised power 4, that means you can say 3 raised power 4 multiplied by x raised power 4. And 3 raised power 4 is 81. So 3x all raised power 4 is 81, x raised power 4. Then you have 2ab raised power 3. So you have 2 raised power 3, a raised power 3, b raised power 3. 2 raised power 3 is 8. So you have 8a raised power 3, b raised power 3, like that. Then we go ahead and talk about the power of a quotient. So we talked about the power of a product. Now, so far we've seen rules like the product law of indices, the quotient law of indices. We've talked about the fraction. Have we talked about fraction power? We've talked about the power of a quotient, product of a quotient. Now we are talking about power of a quotient. We just talked about the product. I mean the power of a product. Now we're talking about the power of a quotient. So quotient is the result of division, right? So imagine a over b. That's the quotient here. So if you raise a over b to a power, you can also have it as a raised power n divided by b raised power n. So why does that work? Again, we have this, that you have 2 all over 5 raised power 3. So that means you have 2 over 5 times 2 over 5 times 2 over 5. That simply means you have 2 times 2 times 2, that's 2 raised power 3. 5 times 5 times 5, that's 5 raised power 3. So at the end of the day, you just have 2 raised power 3 all over 5 raised power 3, which is 8 over 125. Okay, so the exponent applies to both numerator and denominator in this case. So good examples, you have x over 3 raised power 4. So that's x raised power 4 all over 3 raised power 4. That's x raised power 4 over 81. Then you have 2a over 5b all raised power 2. That's 2a raised power 2. That's 4a squared. 5b raised power 2. That's 25b squared, like that. And then we can have mixed laws. We can have mixed laws, or what you can call multi-step simplification. Okay? Imagine that you have x raised to power 3 all raised to power 2 times x raised to power 4 all over x raised to power 5. Of course, the top can be, you can write x raised to power 3 times 2, x raised to power 3 raised to power 2 as x raised to power 6 because you can multiply the powers. And then now that you have x raised to power 6 here, you have x raised to power 4. Multiply both, you have x raised to power 10. And you have x raised to power 5 down. That's x raised to power 10 over x raised to power 5, which is x raised to power 10 minus 5, which is x raised to power 6. And the final answer is x raised to power 5. I feel like I should do this on the worksheet again. X raised to power 3 raised to power 2 times x raised to power 4 all over x raised to power 5, right? X raised to power 3 raised to power 2 times x raised to power 4 all over x raised to power 5. So now in one blow, we can say this is x raised to power 6 here times x raised to power 4 here all over x raised to power 5, and that is x raised to power 6 plus 4 all over x raised to power 5. So that is x raised to power 10, x raised to power 10 all over x raised to power 5. And then the final answer is x raised to power 10 minus 5, which is x raised to power 5. That is what we did just there just now. Okay. Now we have an example. Imagine this example 2. We have 2a squared b raised to power 3 all over a 4b2. Okay, so I mean, if you go through the process, you have 8a squared b, but let me just go ahead and do it on the worksheet. 2a squared b raised to power 3. All right, 2a squared b all raised to power 3 all over a4 b2, like this. So here now we have 2a squared b all raised to power 3 all over a raised to power 4 b raised to power 2. So of course this one simply means you can have 2 raised to power 3, a squared raised to power 3, and b raised to power 3 all over a raised to power 4 b raised to power 2. Okay, and 2 raised to power 3 is 8. Then we have a raised to power 8 squared raised to power 3, that's a raised to power 6 if you multiply, and this is b raised to power 3 all over a raised to power 4 b raised to power 2. And then we can go ahead and say this is okay, 8 a raised to power 6 all over 4 times b raised to power 3 all over b raised to power 2. We can split the things up like this, and then we have 8 times a 6 minus 4 times b 3 minus 2. Okay, because they are dividing, and then we have 8 a raised to power 2 b raised to power 1. All right, so our final answer is 8a squared b, like that, for that problem. Okay, so 8a squared b. For example 3, I'll just read it from here. You have, for this example 3, you have x squared y raised to power 2 xy cubed. Okay, well, I feel like I should still do it on the other page, but see what is done. If you simplify inside, you have x squared y. Okay, maybe the subtraction is done first of all, and then it is now squared later. But you can look at this process, but I'll just do it my own way. On the other page, you have x squared y all over xy cube all raised to power 2. Okay, so here we have so we have x squared y all over xy cube all raised to power 3. So you can do this in different ways. You can simplify inside first before you raise it to the power. Oh, it's power 2, sorry. You can simplify inside first before raising to the power 2, like it's done there. But here, I want to do it in another way. I can say this is x squared y raised to power 2 all over xy cube raised to power 2. I can do it that way. And that means I have x squared squared y squared all over x squared y cube squared. So I can do this. So I then have x raised to power 4, y raised to power 2, all over x squared, y raised to power 6, because we can multiply powers. And then from here now, I can now say I have x raised to power 4 minus 2, because we have x and y like that. Then 2 minus 6 here. So that means I have x raised to power 2, y raised to power minus 4. So anyhow you do it, you get the same results. So what is done on this page is that you simplify inside for that's x raised to power 2 minus 1, then y raised to power 1 minus 3, and then you square. So if you want to remove negative index, you can then have x squared over y raised to power 4. Like in this case, we can do the same. Now this is x squared times 1 over y raised to power 4. That means we have x squared all over y raised to power 4, like that. So that's what we have there. Okay. Um, yes. So that happens. So in summary, we see that we have five laws. We have the product law, which tells us that a raised to power m multiplied by a raised to power n is the same thing as a raised to power m plus n. We have the quotient law, which is that a raised to power m all over a raised to power n is the same thing as a raised to power m minus n. And then we have the power of a power, which tells us that a raised to power m raised to power n is equal to a raised to power mn. And then we have the power of a product, which says that a multiplied by b all raised to power n is the same thing as a raised to power n multiplied by b raised to power n. And we have the power of a quotient, that is a over b raised to power n, which is equal to a raised to power n all over b raised to power n. That's the summary of the laws of indices: product law, quotient law, power of a power of a product, and power of a quotient. Okay. So we have some practice questions we can try our hands on, 20 of them as usual. So maybe I can show them in fives. So practice question: simplify each expression fully. Give answers with positive indices where possible. So it means if you have a negative in this index, you have to change it to a reciprocal, right? So for this ones, of course, this is just x raised to power 8, this is a raised to power 11, this is y raised to power 7, this is m raised to power minus 2, because we have 6 minus 8. This is x raised to power 12, this is 4a6, 4a raised to power 6. This is um one this is 125 x cube y cube, of course. So from 8 downwards now, still 8 downwards. So from 8 to 12, say 3a over b squared, that's 9a squared over b squared. This is x raised to power 10 over x raised to power 6, that's x raised to power 4 altogether. This is x raised to power 10 over x raised to power 4, that's x raised to power 5. This is a raised to power 4, b raised to power 6, because we multiply the powers. Then for 12, we have 4 over 2 x raised to power 5 x. So this will be 2 all over x raised to power 3. I mean 2 times x raised to power 3 rather. And here we just have x squared y, basically, because there's no power here. Then we have 14 downwards. So for this now we have x raised to power. Okay, maybe it's easier to simplify inside before we square, right? So we have x squared over 2, that's x y squared raised to power 2, that's x squared y4 at the end of the day. Okay, for 15 now. Okay, we have 15 to 20 now. So cube of this, that's 27a6b3. Then this is 4x6. This is x raised to power 4. So 4x6, x raised to power 4, that's 4x2. Then a5b2, a2b6, that's a3b minus 4, right? a3b minus 4. And for this, we have x12, y8. Here we have first of all, we have x8 y6 over xy squared. So x8 over x, that's x7, y6 over y2, that's y4. So x7, y4. And this is cube, right? We have at the top we have 8a6 b3 all over 27 c3. 8a6 b3 all over 27 c3. And that's all about this video on laws of indices. Let me know how helpful this is for you. And if there's something you'd like me to try out, feel very free to let me know. If you have subscribed already, I must thank you very much for doing that. If you haven't subscribed, what are you waiting for? Go ahead, hit the notification bell so that you can always get alerted. Subscribe, right? And hit the notification bell so you can always get alerted each time a new video is released. After that, you can also become a member of this channel by clicking on join. That gives you some special privileges, like seeing some videos first, or being the only one to see some certain videos as a member of the channel, or hanging out with me to talk about anything that interests you on the channel. And of course, ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.